Students, myself Archana Varude. In last video, we studied about what is by reflection, about refraction, and what are the laws of reflection and refraction. And in today's video, we study about total internal reflection. It is also called as TIR. What is by critical angle and which are the conditions for total internal reflection. Before going into the details of total internal reflection, we must know about reflection and refraction. When light falls on surface like glass or water, then some part of light is reflected in the first medium and some light passes in the second medium. That is, reflection and refraction takes place. And as the refraction is the property of light, on account of which light changes its path, that means it bends when it enters from one medium into another medium. This topic we already studied in last PPT. Here, when light enters from air medium into glass medium, that means from optically rarer medium into optically denser medium, then the ray bends towards the normal. And if the light enters from glass into air, then the light ray bends away from the normal. These are the two cases. And also we have seen that as angle of incidence increases, then angle of refraction also increases. And the maximum possible angle of refraction is 90 degree. And corresponding angle of incidence is called as a critical angle. And if the angle of incidence increases above the critical angle, then refraction does not take place. That is, absorption does not take place and only reflection takes place. And now we see what is meant by actual total internal reflection. For that, observe this diagram. Here, consider these light rays from a point source in optically denser medium, that means glass medium, fall on the surface of the other side of which lays optically denser medium, that means air medium, as shown in this diagram. Then here, this is the normal, or if the angle of incidence is 0, then it goes back in same direction, that is called as a reflection. But if the angle of incidence increases, then see these arrows. This is angle 20 degree, angle 30 degree and angle 40 degree. Then it is observed that for these angles, refraction and also reflection takes place. But observe this particular angle. At this angle, it is observed that the angle of refraction is 90 degree, which means that the refracted ray runs along the interface. And after that, when we observe these rays, then here the angle of incidence is larger than this angle. And there is no refraction and only reflection takes place. And this is called as a total internal reflection. And thus, as angle of incidence increases, then a situation is reached at which the refracted ray points along the surface. And here the angle of refraction is 90 degree. And for the angle of incidence larger than this critical angle, then no refracted ray exists. Only that light is reflected. That means only reflection takes place. And giving rise to a phenomenon, it is called as a total internal reflection. Here, see this. This is the particular angle at which angle of refraction is 90 degree, and therefore that angle is called as a critical angle. And this is a light source. And when we observe these rays, here angle is 20 degree, then angle of refraction is 27. If the angle of incidence is 30, then that angle of refraction also increases because it is coming from denser medium to rarer medium. And as we know that when light enters from denser medium to rarer medium, then it bends away from the normal, and therefore angle of refraction is greater than angle of incidence. And from this, the definition of total internal reflection is if light is traveling from high refractive index to low refractive index, and if the angle of incidence is greater than critical angle, then only reflection takes place, which is called as total internal reflection. Then we see what are the conditions for total internal reflection. Here, first condition is the angle of incidence should be greater than critical angle, and that critical angle may be denoted by I suffix c or theta suffix c. Then second condition is refractive index of first medium should be greater than refractive index of second medium. These are the two conditions for total internal reflection. Then what is the definition of critical angle? And as we see in the earlier slide, the angle of incidence at which angle of refraction is 90 degree is called as a critical angle. And if the angle of incidence is greater than critical angle, then only reflection takes place. And after that, only total internal reflection takes place. And the whole phenomenon is called as a total internal reflection. That's all about today's video. I hope you all understand what is by total internal reflection, how it takes place, what is the definition of total internal reflection, what is meant by critical angle, and what are the conditions for total internal reflection.